Hello, so we are going to talk about chapter 6, continue to talk about the chapter 6. And so let me share my screen with you as usual. The first part we will look at. Remember in last video, we talked something about reading text files in PCs. And I think the problem for me in here is that, okay, if I just run them, but then I will not know anything about how to do it by myself. So I will still input something, input like the yeah, the code here. So we have so our read CSV. Okay, I may need to run all of them from the beginning. So we can see we have read CSV, we have read tables. Sometimes we need to read tables, read a table, right? Because we need to separate them with some space, which we don't know it is what CSV or not. So we will use read table. So when we use read table, we can use this sep parameter, and then we reading text files in pieces, which is result read.c. So which this is a big one, a big data frame. There are many rows. Actually, it's not that much because there are more like billion, not billion, sorry, like 1 million or like 10 million transactions all day. And so what we will do is, okay, we can read in some like part of them, like 5 rows first, and we can also read with chunk size and what is chunker. So we can see, okay, for everything in chunker, what we are doing is to add the key value counts to this chunker. So what's in total? What's in total is the thing we want to look at, right? So in total, this is a value counts of everything in the chunker. So what I can think of is, okay, because I only use this key column here, right? So the key column is a categorical variable. So what I use is value counts, but for example, I can also change it to 3. Like, okay, what I want is sum. Okay, we got nothing here. And why? Because let's see what's in piece, P-I-E-C-E. So piece is 1,000 rows here, right? And the mean, how about mean? So we have total, we have mean. Okay, my light is off. Let me check what happened. Okay, I want to open my light. Okay, there is no mean. Oh, no mean here because, okay, there must be something wrong, right? So for 3, okay, I think that is maybe something wrong here. So that's the right way to identify this column, which is 3, and what I want is min. Okay, total. After this was in total. Okay, still it is blank and I don't know what happened. So let's see what is print. What is this mean? Okay, this isn't a mean. And what we are doing is add mean. And I do not want to fill an A. Okay, so what do I have? Still, it is empty. So what happened here is that the default D type of empty series will be object instead of float 64. In the future version, specify a D type explicitly to silence this warning, which is weird. And so I will leave this problem here, and we can think about it, why I have this problem, right? So maybe there is something wrong, like append. There is no such thing. It's add. Okay, and the total is still a blank series after all these or this for loop thing, right? So, okay, let me go to the next part, which is writing data to text format. So we still read in text format. We still read CSV, and the next thing we will look at is, okay, what's in here, right? So this is what's in there. There are 1, 2, 3, 4, 5, 6. There are 6 columns. 1, 2, 3, 4, 5, 6. Oh, sorry. The one should be the first one should be index. So 1, 2, 3, 4, 5, and there is nothing in first row, where there is nothing in the first last column. And then we will look at, okay, so so we return to sys dot standout std out. So it prints the text result to the console. So we import sys and the data to CSV. Okay, look like this. And then missing values appear as empty strings in the output. We want to denote them by some other centennial value. Use none. So here's none instead of blank. And then the next thing we will do is to, so with no other options specified, both the row and the column labels are written. Both of these can be disabled. For example, we don't want index, we don't want header, and right. And the next part for us is that we want to set the name to CSV, which is, so we want to write only a subset of the columns and in the order that we choose. So series has a toCSV method. So series here also have this method, and then we can check what happened. So we have a data range period is 7. And what can we get? What's in days? Okay, there are 7 days, or so we can maybe write, okay, for a year, right? So this is for a year. Okay, I want this, the current year. Right, so this is what we get, and at the same time we have, okay, we have TS, which is, so for TS we have, okay, and our index is the dates. So every day we have a number until the last day, and then we want to, okay, I want to CSV and exam, like chapter .csv. So we can check if it is there or not. So right now we are in we are in a Python, not think Python. We are in a folder which the folder's name is Python. Okay, this one. And then we can see, do we get what we want? Do we get that? So where did I put that? Let's check. Okay, it's should outside. It should be here actually. And the name is chapter 6 CSV. Let me check in this folder. Okay, yeah, it's here and okay, chapter 6 folder, and let's check the path. So the path is, yeah, it's outside. It should be in here. Okay, it's here. And we can open it and to find out what's in there. Okay, see there are two. This is index, this is the column. So yeah, that's all about that. And then we can go to the next part, which is, okay, now I save it and I want to look at it. So what should I do is use this example, XAT, and yeah, so I can see it. So next part we will look at is working with the limited formats. So it's possible to load most forms of tabular data from disk using functions like pandas read CSV. In some cases, some manual processing may be necessary. It's not uncommon to receive a file with one or more like lines that strip up read CSV to illustrate the basic tools. We can consider a small CSV file, which is exercise 7. And then we can do CSV dot reader. And okay, we didn't see anything here, right? So for any file with a single character delimiter, we can use Python's built-in CSV module to use it pass any open file or file-like object to CSV.reader. So iterating through the reader like a file is tuples of values with any quote characters removed. So for line in the reader, let me put a for line in reader, print line. Okay, there are only 3 rows. And so from there, it's up to us to do the wrangling necessary to put the data in the form that we need. And let's take this step by step. First, we read the file into a list of lines. So what we will do here, okay, I have lines, and then we split the lines into header line and the data lines. So how to do it? We read everything in these lines. Let's print it to see what's in there. Okay, right. And then we have header, and we have lines. And so what we will do is okay, header is here and the value is here and lines 0 and lines the rest of it. Okay, and then the next steps is we create a dictionary of data columns using a dictionary comprehension and expression zip. So we can transpose rows to columns. So here, which I think is very interesting, that Okay, v for h, v zip header, zip values. So let's see what's in here. Zip header, zip values, right? Are you curious what's in here? Okay, we cannot see, but what we can do for HVN, right? We can print. If you don't know what's in there, what you can do is, okay, we have H, which is in, which is column name. We have V, which is the value, and then we want to, so H is column, right? So here is a dictionary, and we can actually assign this dictionary into a data frame. So that's what we want, right? So CSV files come in many different flavors to define a new format with a different delimiter, string quoting convention, or line terminator. We define a simple subclass of CSV dialect. We know dialect is kind of like some language that just speak in a region, which is maybe is quite different from the language, your language that you speak. They have different like accent. So yeah, so for CSV dialect is, it's a simple subclass. And then what we will look at is, okay, we can, so in this class, and what we are doing here is, okay, said that argv1 must be an iterator. Right? And so argument 1 must be an iterator. There are some of the errors come out. We can also give individual CSV dialect parameters as keywords to CSV reader without having to define a subclass. So the possible options that also the attributes of CSV dialect, including like delimiter and the line terminator and the quote char, and also quoting, skip initial space, and double quote, and escape char. Okay, so there are many things that we can choose from the dialect. So my dialect, why we read in, this one is reading in F, and okay, I cannot run the things successfully here, so I don't know where the problem is. And okay, this is my second question of today. So the first one is the question here, why it cannot work, why this total is still blank. And the second question for me today is about this, is why this my dialect cannot run successfully. So where the problem is. And then let's go to check the next one, which is JSON data. So for JSON has become one of the standard formats for sending data by HTTP requests between web browsers and other applications. It's a much more free-form data format than a tabular text from like CSV. So it's more free-form data format. So here is an example. And yeah, I met this before. It seems like a lot of, it is a big dictionary, and what we have, the first is the column name and the value. Then there will be a lot of things here, a lot of columns here, so a lot of records here. So So the next thing is, okay, we import JSON and use JSON loads, and this is the result. Look, it's very different from the tabular data frame, right? And JSON is very nearly a valid Python code with the exception of its null value now and some other like nuances such as disallowing trailing commas at the end of list. The basic types are objects, like dictionaries, arrays, like lists and strings, numbers, booleans, and nulls. All of the keys in an object must be strings. There are several Python libraries for reading and writing JSON data. We will use JSON here, and it's built into the Python standard library to convert a JSON string to Python form using JSON loads. So we can see that actually we have already done that here. And the next thing is that we use JSON.dumps, converts a Python object back to JSON. So right now we put something back into JSON. So let's see what is a as JSON. See, it is pretty same with the original object. Then we want to convert a JSON object or list of objects to data frame or some other data structure for analysis. Actually, it's up to you. So we can pass a list of like dictionaries to a data frame constructor and select a subset of data fields. How to understand this? Let's check this data frame, which is there are two columns and okay, just a row and two columns. And then we read in this example JSON. So we read this JSON and yeah, we can read this JSON. We use read JSON to turn the JSON data sets in arrangements into a series or data frame. And what else we can do is to like save JSON. We want to export data from pandas to JSON. One way to use to JSON. So it's not that hard actually, because yeah, because we can see that there are ways for us to read a JSON and or also to save it into JSON. So I think we just talk something not a very, some shallow or some basic knowledge of JSON here. So next part we will talk about XML and HTML web scraping. Okay, which I have done recently to scrape some of the people, actually some people's resume, some people's like records on LinkedIn, and to find out which one we should hire. So we should hire, which I think is very interesting for human resource people if they, I think they must use something actually, some web scraping like tools that when they input or help them to find their candidates on LinkedIn automatically. So I think it's very important project for me to do. So the web scraping. Yeah, so let's check the web scraping here, which is okay. We have so the first like library I want to let you know is XLXML, and yeah, Beautiful Soup. That's also the one that I use. So we use read HTML, and so it will read the HTML files as data frame objects, and so we download. First, we need to install. Okay, see, right now we have this HTML And I don't know if we can find the original one here. So we surely have a original one, which in example file. Let me go to check it. So in HTML file, yeah, it's here, which is the HTML. It's like this. Okay, so this is the website. You can see there are lots of things, but when you use pd.read HTML, and so you can get the tables you want, which is okay. So let's see what's in tables. Okay, the length of the tables is just 1, and what's in tables. Okay, there are a lot of things here, and all right, so the read HTML function has a number of options, but by default, it searches for and attempts to parse all tabular data content with table tags. So the result is a list of data frame objects. And because failures has many columns, so pandas insert a line break character, which is /. So we will learn in later chapters. From here, we could proceed to do some data cleaning and analysis, like computing the number of bank failures by year. So let's see what we can do. Okay, we find, so here is failure, and we want to find the close date. Here is close date. We turn this because I'm very sure this column must be the type of this column must be string or something, not date time. So we need to change it to date time first. So yeah, you can see, okay, it's object. So we need to change it to date time. And then by year, we can see, okay, the close, the failure bank. I mean, in 2010, there are many like bank fail, right? It's not a very good year for banks. Then let's go to the next one, is parsing XML with XML Objectify. So XML is another common structured data format supporting nested data with metadata. So we use read HTML function to read HTML, and XML and HTML are similar, but XML is more general. So we will show an example of how to use LXML to parse data from a more general XML format. The New York Metropolitan Transportation Authority published a number of data series about its bus and train services. So we look at the performance data. Yeah, so this is XML. And what we will do is we will use XML Objectify. We parse the file and get a reference to the root node of the XML file with get root. And then root indicator returns a generator yielding each indicator XML element. For each record, we can populate a dictionary of tag names to data values. So that's what we do here. And then we can get a data frame, which is amazing. I think this part I need to do more study because I think it's very interesting to from XML to a data frame, right? So that's the result. So XML data can get much more complicated than this example. Each tag can have metadata too. For example, consider an HTML link tag, which is also valid XML. Google, it must be very difficult so we can access any of the fields in the tag or the link text. So actually in my way, I use Beautiful Soup and also I get everything that around the thing that I want and also I write a class. So it's pretty complicated, but maybe I can use this to help me to achieve that part. So for the binary data formats, so one of the easiest ways to store data efficiently in binary format is using Python's built-in Pickle serialization. So pandas objects or have a toPickle method that writes the data to disk in Pickle format. So this is a way to actually to help us to know why we need to write things to Pickle, because we can read any pickled object stored in a file by using the built-in pickle directly. And a pickle is only recommended as a short-term storage format. The problem is that it's hard to guarantee that the format will be stable over time. An object pickled today may not unpickle with a later version of a library. We have tried to maintain backward compatibility when possible, but at some point in the future, it may be necessary to break the pickle format. So if you wanted to store it in the short time, use pickle, otherwise do not use it. Okay. So pandas have built-in support for two more binary formats, HDF5 and message pack. Then we can know that this more later. So for example, we can using HD5 F5 format. So it is a well-regarded file format intended for sorting large quantities of scientific array data. It's available as a C library, and it has interfaces available in many other languages, including Java, Julia, Matplotlib, MATLAB, and Python. HDF stands for hierarchical data format. Each HDF5 file can store multiple data sets and supporting metadata. Compared with simpler formats, HDF5 supports on-the-fly compression with a variety of compression modes, enable data with repeated patterns to be stored more efficiently. HDF5 can be a good choice for working with very large data sets that don't fit into memory. And when it's possible to directly access HDF5 files using either the PyTables and H5 PY libraries, Pandas provides a high-level interface that simplifies storing series and data frame object. So here we have this frame, which is a data frame, and so the HDF store class works like a dictionary and handles the low-level details. So let's check. Okay. It said missing optional dependency tables. Okay, we needed to install. Let me do that. Okay. Pip install tables. Actually, I don't know what's tables mean because we didn't use tables. Okay, it's here. It works. Okay, so objects contained in the HDF5 file can then be retrieved with the same dict a dictionary like API. So I use this store obj1 to call it back. And HDF store supports two storage schemas, fixed and table. The latter is generally slower, but it supports query options using a special syntax. So store put. Okay. So my data H5 is not open. How to open it? How to open it? I do know the put is an explicit version of the store object 2 frame method, but allows us to set other options like the storage format and then the pandas. Okay, OS is not defined, so we also need to import OS. So pandas read HDF function give us a shortcut to these tools here. And so if we work with large quantities of data locally, we encourage you to explore PyTables and H5PY to see how they can suit your needs, since many data analysis problems are I/O bound. Using a tool like HDF5 can massively accelerate your applications, which is great. Okay, so the next part, which is reading Microsoft Excel files, we can read by PD Excel file. We can also read Excel and to choose a sheet that we want. And what we can also do is Excel Writer. Okay, actually I always use pd.read Excel. And if we want to write pandas data to Excel format, we must first create an Excel writer, then write data to it using pandas object to Excel method. So there are two steps here we need to remember. Okay, X here. We need to pip install XLRD at first. So pip install XLRD. Okay, still not defined. Okay, not supported. Why it cannot be supported? There are problems again for me. Okay, so look at these errors. We needed to start from the error. So I think that is because maybe the first, the XLRD, which is Excel file not supported. So let me check what the problem is. So linked to from the release tweet said that make sure we are on a recent version of pandas, and then we install OpenPyXL. Okay, let me to install this one and see what happened. So I will also install this one, which is pip install. Okay, it's still not work. And let me go to the next part, which is interacting with web APIs and interacting with databases. Then this chapter will end there. So interacting with web APIs, many websites has public APIs providing data feeds, while JSON or some other format. There are a number of ways to access these APIs from Python. One easy to use method is request package. To find the last 30 GitHub issues for pandas on GitHub, can make a get HTTP request using the add-on request library. So we have this request library and read everything in JSON, and this is the latest 30 problems. So the response object JSON method will return a dictionary containing JSON passed into native Python objects. So I have ever done a project which is to extract the data from Twitter and to connect the Twitter's API, which is also very interesting. So that's what we use in here. And each element in data is a dictionary containing all of the data found in GitHub issue page, can pass data directly to data frame. And so that's all about how we interact with the Vibe APIs. So I actually know more about this part. So I want to review my project, and then we can know more about this part, how to get data from APIs. Next thing is about interacting with databases. So most data may not be stored in text or Excel files. SQL-based relational database such as SQL Server, PostgreSQL, and MySQL are in wide use, and many alternative databases have become quite popular. So loading data from SQL into a data frame is fairly straightforward, and Pandas has some functions like SQL SQLite 3, and we can write. So I think that part is not that difficult. The only thing that we need actually is, I mean, when you work in a company, you may need to find IT. First, you need to get access to a database, right? So if you want to write something here, then you need to find the people who manage the database to get the user, for example, username and password and port and other like parameters. Then you can connect the database, just use Python, which I have already done a lot of work there. And also when you connect to different, you can even actually connect to Amazon, to AWS, right? With something here, and also write SQL queries and do the data pipeline here in Python. So I will not talk too many things about that here. And I mean, there are lots of packages for us to connect with different database. So SQLite is just one part. And yeah, that's all I want to talk about in chapter 6. And we can stop here, and I will start to talk about chapter 7 in the next video. So I think I need, yeah, I must need 2 videos to talk about chapter 7. So bye.